Volcano underwater volcanoes. Oases of the sea. Captured by HD cameras by ASHRAF Omar, April 2025. Far beneath the ocean's surface, where sunlight fades and pressure mounts, exist fiery giants that most of the world never sees. These are underwater volcanoes, or submarine volcanoes, and they are more than just molten mouths of fire. Recent high-definition footage from deep-sea exploration missions has revealed an astonishing truth. These volcanic vents are thriving underwater oases, teeming with life in one of the most extreme environments on Earth. Thanks to cutting-edge HD cameras mounted on deep-diving submersibles and remotely operated vehicles, ROVs, we're now getting breathtaking footage of this hidden world. And what scientists are seeing is transforming how we understand both volcanoes and marine life. Fire. What are underwater volcanoes? Underwater volcanoes form just like their land-based counterparts, when tectonic plates shift and allow magma to rise through the Earth's crust. But instead of spewing lava into the sky, these volcanoes erupt into the cold, pressurized darkness of the deep sea. The result? Explosive pillars of superheated water, rich in minerals and chemicals, pour into the ocean and create hydrothermal vents, natural chimneys that support bizarre and beautiful ecosystems. There are an estimated more than 1 million submarine volcanoes around the world. Many of them lie along mid-ocean ridges or near tectonic boundaries in places like the Pacific Ring of Fire and the Mid-Atlantic Ridge. Movie camera capturing the abyss. HD cameras dive deep for decades. These deep-sea volcanoes remained mysterious and inaccessible. But recent breakthroughs in robotics and imaging have changed everything. Submersibles like NOAA's Deep Discoverer and Japan's Shinkai 6500, equipped with Ultra HD and even 4K cameras, have descended thousands of meters below sea level to explore active volcanoes. What they found is nothing short of cinematic. HD footage reveals eruptions of black smoke, actually mineral-rich water blasting out at over 300 degrees Celsius, shimmering colonies of tube worms and crustaceans thriving in boiling water, lava rivers slowly carving the seafloor. Brightly colored bacteria mats that feed off chemicals like hydrogen sulfide, unique species like blind shrimp, giant clams, and vampire squid. One explorer described the scenes as alien landscapes glowing with life. Wave. Why they're called oases of the sea, despite being surrounded by freezing water and pitch black conditions. These volcanic sites serve as life-generating hotspots. They provide chemical energy instead of sunlight, allowing a process called chemosynthesis to occur. This is where bacteria convert the volcanic gases into nutrients, forming the base of a food chain that includes exotic worms, crabs, and deep-sea fish. Some scientists believe this is how life on Earth may have first begun, not on the surface, but in the depths of volcanic oceans. Because of their isolation and harsh conditions, many of the species found near underwater volcanoes exist nowhere else on Earth. That makes them not only biologically fascinating, but also critically important for conservation and biodiversity. Globe impacts on climate and science. These volcanic vents also play a subtle but significant role in climate regulation. They release minerals that feed plankton blooms, which absorb carbon dioxide from the atmosphere. Researchers are even exploring ways to study underwater volcanoes to predict surface eruptions, earthquakes, and tsunamis. Moreover, deep-sea exploration is inspiring new biomedical research. Enzymes from heat-loving microbes found at volcanic vents are now used in DNA testing and could hold the key to future medicines. Rocket. What's next? The final frontier beneath the sea. While we've mapped Mars more thoroughly than our own ocean floor, each new dive with HD technology brings us closer to understanding Earth's final frontier. With future missions planned by NASA, NOAA, and international oceanographic institutes, scientists hope to document more eruptions in real time, discover new species, and perhaps even uncover clues to life beyond Earth, since similar vents might exist on the icy moons of Jupiter and Saturn. Glowing star final thoughts: underwater volcanoes are no longer just deadly geological curiosities. They're gateways to vibrant ecosystems, mystery, and possibility. Thanks to the power of high-definition underwater imaging, we can now witness these explosive marvels as never before, and realize that even in the deepest, darkest corners of our planet, life not only survives, it thrives.